Hi everyone, this lesson is for Algebra 2 Honors students. This is Chapter 6, Section 6.8 and 6.9, Introduction to 6.9. And we are doing exponential equations solved by logarithms. This is logarithms, and let's get started. We have learning targets, and those are to solve an exponential equation with any positive constant base, as well as using base 10 logarithms. We are going to learn the definition of a logarithm by finding a logarithm, also showing the graph of it or base argument, and finding one or the other if the other one is given. This is just some information, just like back in the day. This was actually the calculator that I used when I was growing up, and it is called a slide rule. Yeah. All right, so what are logarithms? Well, logarithms are the inverse of an exponent. And little background about calculators. Before calculators came around, we used slide rules, and also base 10 logarithms or common logarithms were used to simplify common applications. So we use, instead of saying logarithm every time, we abbreviate that and we say log. We don't have a base that's written because we are base 10 system, meaning we have 10 digits, and that's what our mathematical system is based on. And so, good word, base. So what that would look like is something like this. If I said, let's say log 3, there's actually under here where you can't see that is a little 10 because we're base 10. So like on all the calculators, it's automatically assumed that you are base 10. So we don't write that. And so what ends up happening is, your calculators are base 10, but you're also able to change that base pretty easily on a calculator. The abbreviation log with no base written is used to represent common logs, or what we call base 10 logs. So what I'm showing you here is, well, actually, I'm just going to keep talking. A logarithm is the inverse operation to exponentiation. So that means that a logarithm of a number is the exponent to which another fixed value, the base, must be raised in order to produce that number. So let's say we have this. We have log base 10 of 10. And what does that equal? This is what it looks like. Technically, this is it right here. And you're saying, well, I wonder what that equals. So what that equals is this. In order to change from a logarithm to an exponent, okay, which is its inverse, then you're going to do this. It's going to be 10. You're going to take the base, which is base 10, and you're going to bring it across to the x power. So you're basically saying 10 to the x power is equal to this value here, and that value is called the argument. So 10 to the x power is equal to 10. Now we already know that 10 has a 1 here. It's a power of 1. Now in solving an exponential equation like this, if the bases are the same, you can set the exponents equal to each other. So then x is equal to 1. Solving a system, 1 goes in a solution set. So log base 10 of 10 is 1. So I wonder what would happen if we add log base 5 of 5, right? What would that give you? And if you're right, if you assume that it's going to be 1 also. For this problem here, this is saying log base 10 of 100. And 100 is equal to x. We're trying to figure out, well, what does that equal? So again, you're going to go base to across the equal sign. So you're going to say 10 to the x power is equal to this value, which is the argument. So that's 100. And then I'm going to say, well, I'm trying to get the bases the same. So 10 to the x is equal to 10 squared. So that means that x is equal to 2. And then we're done. Okay. So in this problem here, this guy, John Napier, he's been dead for a while, but he, a long time ago came up and discovered logarithms, which is super cool. And a logarithm, again, is the inverse of an exponent. So let's try to graph that, right? So if I were to graph that, see if I were to say 10 to the y power. So if I said 10 to the y power, that's going to equal x being the argument. If I were to plug values in to this, I would say, well, let's plug in values for y, right? So here's x, here's y. Let's plug in values for y. So if I plug in, I'm always going to plug in 0, 1. Whether I'm plugging in for x or y, I'm always going to plug in 0, 1. So if I plug in 0 for y, that's saying 10 to the 0 power. Well, 10 to the 0 power is 1. And if I plug in 1 for y, I get 10 to the 1 power, which is 10. So if plotting these 2 points, right, I get 1, 0, which is here, 1, comma 0, and I get 10, 1, which is right here, and there's your 10, 1. Okay, and so that's a logarithm. That's base 10, that's log x. Log base 10 of x, that's the graph. And if you notice this part here, of course it goes like this, right? Goes through that, keeps going. And then this, what it does is it gets really close here, but it doesn't ever touch the axis, because what'll happen there is there's no value there. It's undefined. So this right here is what we call an asymptote. All right. Now think about this. If an inverse, and you know from just, I don't know, algebra, that inverses are changing your x and your y, right? So if that was the case, then if I were to say, well, the inverse of that, if 10, what's the inverse of 10 to the y equals x? So the inverse of that would be taking my x and y and flipping those numbers. And so that would be 10 to the x power is equal to y. That's the inverse of a log. And so in graphing that equation, right, here's x, here's y, I'm going to plug in again 0 and 1 for, in this case, x, not y, but x. And 10 to the 0 power is 1. And then 10 to the 1 power is 10. So in graphing this, I would actually get 0, 1, and I'd get 1, 10. Now keep in mind, I'm not graphing a log. This log is going to have an asymptote here. But I'm graphing this exponential equation right here. And that's going to go up like this, right? And so what ends up happening is another way of showing this, and we are going to actually cover this later, is that, remember this line right here, this line, which is y equals x, anything reflected across that axis is what we call an inverse. And so if you were to look at this and you were to reflect it like that, that's the inverse. So there's another way of doing this is graphing. So remember these points, this is 0, comma 1, and this point here is 10, 1. And so again, those are inverses. That's kind of cool. So base 10 log, we have y equals log base 10 of x. And if and only if 10, this here, go across the 10 to the y power, base to a cross equal sign, is equal to x. So trying one of these problems here, we have 10 to the x power is equal to 457. So I want to rewrite that. See, I'm given this. Now I have to go backwards. So in order to go backwards and make it into a logarithm so I can solve for x, I need to get this variable out of the exponent spot. And in doing that, when I pull that out, that x comes out, that becomes a log. So you do this. You go x log 10 is equal to log 457. And so what's happened here is that you are trying to isolate the x. You're trying to solve for x. You need to get rid of this log base 10 of 10. And so basically I would divide by that, right? So I'd say, well, that's log of 457 divided by log base 10 of 10. Well, we already know log base 10 of 10 is 1. So realistically, x is going to equal log of 457. So in doing that, you're going to use a calculator actually to solve that. So we're going to go x is equal to, get your calculator out. You're going to find the log button. The log button is going to be above the 10 to the x, because you know on a calculator, they always put the inverses of each other, right? The inverse of a square is a square root, right? The square root, the inverse of a log is an exponent. So what you're looking for is something that has either log on top or bottom, and then the button is either like 10 to the x or it's flipped, okay? Depending on your calculator. So you're going to go type in log. So we're going to say log. If you have the TI Inspire, you're going to use the arrow key to go over, unless you just want to plug in base 10. So you're going to say log base 10 of 457. Now, unless you put, if you have the TI Inspire, unless you put a decimal next to the 457, like right here, you're going to get exactly what you just wrote. So they're a little bit tricky in that you need to put either a decimal or you hit second approximate and it'll approximate your answer. And so hit enter, I get 2.65992. So 2.65992. We're going to go 4. 1, 2, 3, 4. So we're going to go 4 after the decimal point. And so there we go. And that would be my answer. Approximately, because I cut this off. And so actually, you're going to need to do this with your approximate, right? With your equal sign. So again, the inverse of an exponential function is a logarithm. So what they did was they took your x and your y, and an inverse is just taking those numbers and changing them, right? X and y. And so by doing that, now this is going to be x, and that'll be 2 to the y power. Similarly, an inverse of a logarithm is taking this base, a base, to across the equal sign. So a to the y power is equal to x. And so that's the inverse of a logarithm, is an exponent, and this here is a logarithm. So log to a power of 10. So there's two options for this that I wanted to show you. We know there's a 10 here. Okay, so two things. Number one, we already know that log base 10 of 10 is 1, which means then it's 1 times x. Well, 1 times x is x, and then we know x is x. So that's done. Another option to do is the way you change the base and take the inverse. So you're going to say base to across the equal sign. So you're going to say 10 to the x power is equal to 10 to the x power. Yes. So this is actually a property of a logarithm of a power of 10. So this is a true statement. You're not doing anything to this problem. You're just saying, oh, I'm verifying that it's true. For this problem, we are going to try to solve for x. So we want to get x isolated. So the first thing we're going to do is we're going to try to eliminate this 17. So it's 17 times. And so you undo times by division. So we're going to divide both sides by 17. And so we're going to get 10 to the negative 0.4x, 0.4x, is equal to 29 divided by 17. So now, in order to solve for x, we're going to actually have to take the inverse of this exponential equation, meaning anytime you see a variable in your power point, we need to take that out, pull that out. And doing that, the act of removing that from its position and bring it out front is a log. And so we have negative 0.4x log of 10 is equal to log of 29 over 17. Now, what you need to remember, two things. This is an equation. So whatever you do to one side of the equation, you have to do to the other. So if you logged the left side, you have to log the right side. Additionally, we also know that log base 10 of 10 is 1. We did that on the previous slide. So normally we would divide both sides. So let me show you what we would be doing. We would go log base 10 of 10 divided by log base 10 of 10. And we would divide these out. But because we know log base 10 of 10 is 1, technically that's gone. So what we have is negative 0.4x is equal to log of 29 divided by 17. All right. And so in order to find that value, you're going to use your calculator and you're going to say, type in log. Now, something to remember for logarithms, throughout the entire experience here, is to try to use parentheses whenever you can. So when I'm saying log, I'm going to say log of 29 divided by 17. Make sure that that's within the parentheses. Also, if you have the TI Inspire, you do have to put a decimal, or you hit second approximate, typing it in, like you'd have to put a little decimal here to show that you're telling it, hey, I want this to be a decimal answer. So otherwise you're just going to get log of 29 over 17, which is exactly what you put in. So I got 0.231949. And now I'm going to divide both sides by negative 0.4, negative 0.4. And then when I'm done, I'm going to get x is approximately, this is important that you use the approximate buttons. Take your value and just hit the division, divide, because that's automatically going to divide by the negative 0.4. So negative 0.4 and enter. And I get negative, so my answer is going to be negative 0.57987. So that looks like 1, 2, 3, 4. That 8, that's going to become a 9. And so this is my answer. And what I would then do is just check my work and plug it back into the X. If I wanted to make sure, hey, it's a test, I got it right, you know, so you just plug that back in. Again, I know we tried to do a couple of these. We did these with brute force, and that wasn't fun, right? Just keep plugging numbers in. I mean, maybe it was fun. I don't know. But what we want to do is we want to solve for X again. And this is not, you know, we're going to bring this out front. And the difference between this problem and the last problem is that was the base 10, where this is a 6. And so let me show you what ends up happening. So bringing the X out front, we have X and then we have log 6. Is equal to log 152. Now remember, if you log one side, you have to log the other. And so realistically, we want to isolate the X. So that means I'm going to divide both sides by log of 6. So I'm going to do this, log 6, and here I have log 6. And so I get X is equal to log 152 divided by log 6. And I would pause the video for a minute and check your answer. So I'm going to do that while I work out the problem, and then we'll come back and check it. So plugging this into my calculator, I ended up getting log of 152, which is about 2.18, and then dividing that by log of 6, I ended up getting 2.80388. So X is about 2.80388. So 88. Then if I'm rounding the nearest that 10 thousandths, that's going to change to a 9. So X is approximately 2.8039. And then just again, check your answer. You would get 6 to the, use that hat button on your calculator to check 2.8039. You should get either 152 or pretty darn close to 152. So for these problems here, we are going to try to solve for X, and we're going to pull, again, these values out of the exponential place here. That's going to become negative X log 10 is equal to log 4.35. Negative X log 10. And so just keep that in mind that when you're solving these, right, log 10 base 10 of 10 is 1. So this is just 1. So we can actually just make that go away. And we have negative X is equal to log of 4.35. So you're going to type that in your calculator, and then you're going to take the opposite. So X is going to equal the opposite of whatever that is. And so for me, log, so type in log of 4.35 is equal to 6.3. So this will be negative 0.6385. 6385. And there's my answer for that problem. For this problem here, I'm going to divide by 47 first, just like we did in the previous problem. I'm going to get 10 to the x power equals 6.7 divided by 47. I'm going to pull this out, taking the inverse. We've got x log 10 is equal to log parenthesis 6.7 divided by 47. And we get x is equal to this value because this is 1. And so x equals whatever that is. And so in this problem, I'm going to get 6.7 divided by 47. And I'm going to approximate my answer. I get negative. X is approximately negative 0.8460. And for this problem here, bringing this out front, again, we get 10. X log 10 equals log 0.005. And this is 1. So we have x is approximately that value. And so we are going to go let's see, log of, so second log of 0.005. Oops. And in doing that, moving that over, I get 0.005 log of that value. Enter. I get negative 2.3010. Okay, for the next problem, bringing this out front again, we have x log of 10 is equal to log of 0. And this right here is 1, so I have x equals log base 10 of 0. Now that could be a little tricky, right? So plug that in, see what you get. So log base 10 of 0 should give you undefined, because you're going 10 to the x power. So technically, you're saying 10 to the x power equals 0. When are you going to get a value here that is equal to 0? You're not. And so this is going to be no solution, which is undefined. Okay. So these problems here, same concept, same thing. This is part of like your homework. You're going to bring this out front. You're going to get 0.6x log 10 is equal to log 2001. You're going to divide both sides by log 10, which is 1, so that's gone. So we have 0.6x equals log of 2001. So x is equal to log of 2001 divided by 0.6, and that's going to be approximate. So log 2001, 2001, approximate, approximate my answer. Okay, enter. And that I'm going to divide by 0.6. So divide by 0.6, and I get 5.5. So for this value, I'm going to get about 5.5021. All right. And for this problem here, again, take this x, bring it out front. So you have x log 74.1 equals log of 2.68. Now this one's a little bit different because it's not a base, it's not 10, right? So now actually we are dividing. So x is equal to log of 2.68 divided by log of 74.1. And so now you're actually going to work that out, right? You have to divide two different values. So pause your screen for a minute. I'm going to pause for a minute and you guys work that out and see if we get the same answer. So when I did that, I ended up with getting 0.2289, so almost 90. So 0.2290, 0.229, and then 0. So let's see, 0.229. So that's what my x is approximately on this problem. On this problem right here, I'm going to divide by 11. I get 6 to the x power is equal to 12 over 11. Taking this variable outside and front becomes x log 6 equals log of 12 divided by 11. I get x is equal to log of 12 divided by 11. So you want to do that first. And then you're going to divide that by log of 6. Okay, and so it is a little bit tricky, but you do need to do it. I mean, calculators are really smart, but you have to make sure you use enough parentheses if you're doing this all at once. And then when you're dividing, right, it's dividing by the quantity of that value. So if you do it all at one time, that's what you have to do. Plug that in your calculator and you can get that answer. For this problem here, same kind of thing. We are going to take this value. I'm going to make this a little bit bigger. And I'm going to get rid of the 18 first. So I'm going to divide that out. So I get 5 to the negative 0.3x is equal to 0.007 divided by 18. And in order to solve this problem that has a variable as my exponent, I need to pull that out front. So it's going to be negative 0.3x log 5 is equal to log of this. So I might want to redo that, before, but that's the value that I have. And I don't have to. I can just say that I can leave that like that, and I'm going to bring it down a little bit. What do I want to do? I'm going to bring this over to the right. Here we go. And so that's going to be log of parenthesis 0.007 divided by 18. And so now, I mean, you're going to do this in parts, right? So the first thing you're going to do is you're going to divide this number here, log 5, both sides. So I'm going to divide this side and this side by log base 10 of 5. So log base 10 of 5. So now these are going to cancel on the left, and I'm going to get negative 0.3x is equal to this right here, okay? And you're going to plug that in your calculator, and when you do that, then after you do that, you're going to divide by negative 0.3. So x is approximately this value divided by negative 0.3. So I'm going to pause. I'm going to see, let's see if we get the same, we match up our answers. So be right back. You guys make sure you try this. So in working this out, this whole big, problem on that side, expression there is negative 4.87886. And then I took that value and I divided by negative 0.3, and I got 16.263. You can always check your answer by plugging that value back into this equation for x. I do want to say, though, that be careful with your negative signs. You have to make they are the negative signs. You can't make them a minus. So otherwise you'll definitely get an error. So this was, what if the base wasn't 10, like we were doing, base to cross equal sign. So b to the y power is equal to x. Sometimes you're going to get a different base other than 10. Note that, remember, when we're doing this, y is actually called the logarithm. This is the value that you set your equation equal to. That's called your logarithm. B is the base, of course, and that's your base. And then you've got x is the argument. Now remember, x was here, but when I rewrite it, my argument becomes my answer, or my logarithm. My b is always going to be my base. That's going to stay set. And then the x, of course, is the argument. Okay? We do have, and this is what we were saying before, log base 10 of x is the same thing as saying log base 10 of x. We do have this change of base form, which we actually talked about in class, about having a different base, and two steps versus one. Can we just plug that in? I think it was Felix, right, that said that. So that was pretty intuitive. Good job, Felix. Okay, so find log base 5 of 8 equals x. So this is a different base. This is base 5 as opposed to base 10. So we still are going to do the same thing. We're going to take the base right here, 5, and we're going to go across. So base, it's base to across the equal sign, ACR. Oops, sorry about that. To across the equal sign. That's what you're doing. So you're going 5 to the x power equals 8. That's where that came from. But now your x is your variable is in the power position. We need to pull that out. So we're going to bring that out and take the inverse. So we get x log 5 is equal to log 8. And now we're going to divide. So we're going to get x is equal to log of 8. Now we're base 10. You see that? Change of base. Log base 10 of 8 divided by log base 10 of 5. And for this problem, let's do that. Okay, so what you would get is, let's see here, we're going to go log of 8 and point equals divided by log of 5. Be careful how you put this in, okay? I get 1.29203. So this is about 1.29203. So what we were talking about too in class is this. Why couldn't we just type in log base 5 of 8, right? So if you did that on your calculator and actually type this into a TI Inspire, you are going to get this value. You're going to get the same thing. You do need to know this process though, okay? Yes, it's going to save you a lot of time to type it in directly to the calculator and then go right to the answer. But this is a process and you do need to know how to do that. Okay. Log of -2. If you type this on your calculator, okay, just keep in mind, like, what does this equal, right? So you're like, what is log base 10? of negative 2 equal? So we'll call that, I don't know, x. So 10 to the x power equals negative 2. When am I going to square something and get a negative value, right? You're not going to get a real value. It's going to be imaginary. It's not real. And therefore, you would say no solution for this kind of problem. If your argument, this is your argument, is negative. Your argument can never be negative, right? Okay. All right. So this is a little bit of an introduction to 6.9 because this is what you're going to be doing on your Wednesday asynchronous day. And I want to make sure that I can go over a few problems with you on this. So we're going to go base to across the equal sign. So base to across the equal sign. Our job is to find the argument. See the x? We don't know what that is. So these problems are like that. So we're going to go 3 to the negative 4 power, base to across the equal sign, is equal to x. And so x is equal to this, which is 1 over 3 to the 4th power. So then x is equal to 1 over 81. Okay. For this problem, again, these are all base to across the equal sign. So 1/2 to the 7th power. So 1/2 to the 7th power, this is all to the 7th power, is equal to x. And I mean, it's just done almost. So you've got x equals 1 to the 7th. Remember, you have to distribute that exponent. So 1 to the 7th over 2 to the 7th. And that's going to be, we know 2 to the 6th, right? We did this in class, I don't know how many times. 2 to the 6th is 64. So 2 to the 7th is going to be 1 over 64, 128. And this equals x. For these problems, look where the x is. It's not here anymore. The last problems are where the x was. The x was it right here. The x was the argument. We didn't know the argument. Find the argument. For these problems, we know the argument. We want to find x. X is over here. So again, you're going to go base across the equal sign. So you're going to go 2 to the x power equals 8. Now, these problems, I really like these problems. These are really unique because your job is to try not to use a calculator for this. You can, okay, yes you can. And yes you can bring this out front and go x log 2 is equal to log 8. And then you would say, well, what is x equal? X is equal to log 8 divided by log 2. And then you're going to get an answer. But to save time, I mean, does it save time? Maybe. You want to actually try to manipulate this without using a calculator because it will be quicker. Meaning, if I do this, if I think that I can get my bases to be the same value, then that is going to be way quicker because we have 2 to the x power. And remember, 8 is 2 to the 3rd power. So 2 to the 3rd power. So if my bases are the same, I can set my exponents equal to each other, and I know that x is equal to 3. Done. Okay? Way quicker. Again, 1/4 base to across the equal sign. So we're going to go 1/4 to the x power is equal to 1 over 16. Now, you want to try to get the bases to be the same. The bases are on the top level. Okay, I want you to try to bring that value up. And so keep in mind that what you're trying to do here is because your variable, yes, you can pull that out, right? We can still pull this out and we can say x log 1 over 4 is equal to log 1 over 16. And then x is equal to whatever log of 1/16 divided by log of 1 over 4. It's just a lot of typing in, but yes, you can do that. Or you can say, well, I know this is 2 squared. 4 is 2 squared. So I'm going to rewrite, I'm going to reroute this to the right, okay? And in that case, I would say this is 1 over 2 squared to the x. Bringing this up to the top, right? 2 squared down here, that's going to be 2 to the negative 2x. Do you see that? This 2, when I bring it to the top, that 2 comes up, but the power changes, the sign changes, so now it's negative. And then, and that equals this, which is 16, which is 2 to the 4th power on the denominator, right? That's saying 1 over 2 to the 4th. So bringing that up to the top, that's going to be 2 to the negative 4th power. And what I just told you was if my bases are the same, I can set my exponents equal to each other, and I have negative 2x is equal to negative 4. X is equal to negative 4 divided by negative 2, which is 2. And then that's my answer. Okay, so you do have options. These are values of x. Again, same thing. 2 base to a cross equal sign. 2 to the x power is equal to 8. 8 is 2 to the third power. I feel like I just did this. These cancel. X equals 3. But again, right? Yes, if that's something that you like and you're like, hey, you said if we have a variable in the power position, that needs to come out. And you can pull that out. And that would be x log 2 is equal to log 8, right? And then you would divide both sides by log 2, and you'd get x equals log 8 divided by log 2. You're still going to get the same answer, which is 3. For this problem, base to a cross equal sign. So 9 to the x power is equal to 3. So again, yes, definitely you can do that. And you can change, let me bring this up a little bit. And yes, you can change this to be x log 9 is equal to log 3. And so x equals log 3 divided by log 9. And then get your answer, right? But at the same time, I mean, consider 9 can be rewritten as 3 squared. And then you still have an x up here. That stays there, doesn't go away. And then you have that equal to 3. That's 3 to the 1 power. Bases are the same. I'm going to get 2x equals 1. So x equals 1/2. Same thing as I would get if I did this on the calculator. I'm going to get 0.5, which is 1/2. There is something down here that I do want to just let you know of that. I mean, I think you already know this, but log base a of 1 is 0. And then log base a of a, when the values down here are the same, a is a, that's always going to be 1. And that's for any base. We were talking about base 10, right? If we were talking about base 10 of 10, that value here, that's 1. And the same thing is if I said log base 5 of 5, that value is also 1. Okay. For this one, also for tomorrow, this is, again, you're finding the base. And this is the unknown factor here. So you're still doing the same formula. You're going base to a cross equal sign. So you're going x to the 2/3 power is equal to the argument, which is 4. Argument's the answer. The only thing with this is a different problem. Like the other problems are a little bit slightly different. The x is in a different position each time. You're trying to isolate the x. That means you want to get it by itself, but it's got this 2/3 up here. The way you get rid of that 2/3 is you multiply it by its reciprocal. But remember, you have to do that to both sides. So whatever you do to one side, because it is an equation, you have to do to the other. So these are going to cancel, right? These are going to cancel 1, 1 all around, and we get x. Now, for this case, remember the other day we took our variables, our values, and we reduced them as far as we could. This is 4. 4 can be rewritten as 2 squared. And then that's going to be to the 3/2 power. 2's are going to cancel. And we get 2 to the 3rd power, so x equals 2 to the 3rd power, which is 8. Cool, huh? Okay, same thing. 2x to the 2nd power, so we're going to go base to cross the equal sign, is equal to the argument, which is the answer. For this problem, I'm going to try to get rid of this squared, so I'm going to take the square root of both sides, which is the 1/2 power. But remember, I have to do that to both sides, so we have x equals 1 to the square root of 1 over this. This is what you're saying. It's 1 to the 1/2 power, which is still 1, over 64, which I'm going to make that 8 squared to the 1/2 power. Those cancel. So I get 1 over 8. And that's my answer. So neat. Okay, so these are just some practice problems that you're going to see. And, you know, just again, base to a cross equal sign. So 2 to the x power equals 16. Now, I'm trying to get a common base here. And so in doing that, I would get 2 to the x power equals 2 to the 4th power. So x equals 4. Okay, because the bases are the same. I can set my exponents equal to each other. This problem is a problem because you can't have a negative argument. So when I rewrite it, 4 to the x equals negative 16. There's no value that where I'm going to get a negative number. No real value. Okay, so this one is going to be no solution. Okay. 2 to the x power. So 2 to the x power equals 0. Also, you know, you're going to end up getting x log 2 equals log 0. No value. If you plug in 2 to the 0 power, you get 1. 2 to the 1 power, you get 2. This also not going to happen. Not going to work. This one here, base to a cross equal sign. B to the x power is equal to b to the third power. Are my bases the same? Yes. If my bases are the same, I can set my exponents equal to each other. All right. This is kind of a cool thing here. This is 2 log base 10 of 9. And it's like another way of saying, you know, what value would I get? So I would take this little part right here, which is log base 10 of 9, and solve that first. Okay, so what does that equal? So you're going to go 10 to the x power equals, we're going to go 10 to the x power equals 9. I'm going to log both sides. I'm going to get x log 10 equals log 9. I'm going to get x equals log 9 divided by log 10, which is 1. And so I'm going to find what's log 9. And let's see, what is log 9? So we're going to go second log, move it over. I'm going to get 9, and that's 0.9542. So x is approximately 0.9542. And then I would take the number 2, see that? And I would go 2 to the 0.9542 power. So 2, use the hat, to the answer is going to give me 1.937. So this is about 1.94. Okay. Going back up here, we have, this is base 10. So 10, so watch this. This is a tricky one. 10 to the negative third power is equal to, base to cross equal sign is equal to this, which is 0.001. But think about what's 0.001. So that's tenths, hundredths, thousandths. That's 1/1000th, right? And so thinking about that, that's actually 1/1000th. So I'm going to rewrite this. Hold on a second. I'm going to bring this up because that's 1. So think about this. Where's my variable? I don't have a variable. This is 1 over 1000. So actually on this problem, we're not solving for anything because there's no variable, by the way. This is 1. This value here is 1 over 10 to the third power. And when I bring this 10 to the third power up, it becomes 10 to the negative third power. So this problem right here is a statement. We're not solving for anything. There's no unknown. For this problem here, base to across the equal sign. So we're going 6 to the x power. Base, this base right here, base to across the equal sign is equal to 6. If my bases are the same, I can set my exponents equal to each other. If you don't see a value there, it's 1. So you have x equals 1, okay? For this problem, we've got 3 to the x power equals 1. X equals 0. Anything to the 0 power will give you 1. That is tricky. Okay, so winding down, we're almost done. We have 6 to the second power. Rewrite. All they're asking you to do on these problems is to rewrite it. And this also actually is on your SAT too, where they ask you to rewrite these statements and not like solve it, but rewrite it. So 6 squared equals 36. And we just wrote that in exponential form. We're done. 289 to the 1/2 power equals 17. And you know, the 1/2 power is the square root, right? So it's going to end up being 17 equals 17. These problems are asking you to go back, rewrite it from exponential form into log form. So remember, it goes base to across the equal sign. So this base is always my base. So it's going to say log base 64, right? And my argument is my answer. So this right here is my answer, right? That's also my argument. And that equals to the logarithm. Base, so remember, check it. 64 to across the equal sign. Yeah, it does work. So we've got log base 12. So we have base 12, or my argument is my answer of 144 is equal to 2. So again, you're not doing anything. You're just rewriting this. Rewrite in log form again. This is the same thing. Base, which is going to be log base u of v is equal to negative 14. And then this one right here is going to be log base 8 of a is equal to b. So more practice problems, and you at this point have the option of halting and going right to practice. And I'm not sure we'll get this far in class, but we'll have to see. I'm going to keep going because this is good practice. Evaluating the expression, they're trying to figure out what does this equal. So in these problems, you can set this equal to x. This is like the only time where you can say, what is this value? I'm going to set this equal to x. So we're going to go 4 to the x power is equal to 64. So we have 4 to the x power equals 4 to the what power? So we know how many 4s is that. And this option is that's 4 times 4, which is 16 times 4, which is 3. But what I like about this problem, I know x is equal to 3. What I like about this problem is that instead of doing this way, I actually could have said this. I could have done 4 to the x power is equal to 64. But 4 is actually 2 squared to the 2x, right, is equal to 64, which is 2 to the 6 power. And if my bases are the same, I can say 2x equals 6, and again, x is equal to 3. Super cool options. For this problem, we get 4 to the unknown. We don't, what does this equal? 4 to the I don't know is equal to 16. 4 to the x power equals 4 squared. Bases are the same. We get x is equal to 2. For this problem, what does this equal? So we go 5 to the x power equals 125. And keep in mind, I understand, I think some of you may be thinking, hey, if I pull this out, can I go x log 5 is equal to log 125, and then x is equal to log 125 divided by log 5? Yes, you can do that. You will get the same answer. You'll get 3. The reason you're going to get that is because you could do this in your head, right? And say, well, 5 to the x power is equal to 5 to the third power. 5 times 5, 25 times 5 is 125. Bases are the same. X is going to equal to 3. So you can, definitely use your, mind on that. These problems on the left right here, what this is about is this. See the 12s that are the same? That equals 1. And then that's 1 times 144. So if this looks like this, where you've got the base is the same as the base. So see the 12s are the same. Even if I had 2 log base 2 of 5, my answer would be 5. Because this right here is 1. 1 times 5 is 5. Okay? So for this one, 5 log base 5 is 17 is 1 times 17, which is 17. For this one, what does this equal? So we'd go 2 to the x power equals 4, which is 2 squared. Bases are the same. X equals 2. Okay. For this one, it's a little bit trickier, definitely. This is saying 3 base to a cross equal sign. So 3 to the x power equals 1 over 243, right? So take your calculator. What is 243? 4, 5, 6, 7, 8, 9 goes 3 times, right? 243. 243, divide that by 9. I get 27. So this is 3 times 27. So 27 has 3 3s. 3 is another 3. So what this is saying is 3 to the x power equals 1 over 3 to the 4th power. And remember, if the bases are the same, so see that 3 to the 4th power, which is not on my base, I got to bring that up top. And so that's going to be 3 to the x power equals 3 to the negative 4th power. If my bases are the same, I can say x equals negative 4. And so that's the answer. And this last one, we are saying, what does that equal? So we've got 6 to the x power equals 216. And again, I definitely can take that x out and log both sides. But if you can get the bases to be the same value, 216 divided by 6 is 36. That means that this is 6 cubed, 6 to the 3rd power, equals 6 to the x power. X is equal to 3. Okay? These are kind of fun, right? Okay, so natural logs, we're not going to have time today to talk about natural logs, but we will get to that, and I'm going to come back. This will probably be day 2 and day 3 of this week. And so I do want to just say that we do have a natural log. We did talk about that in class a little bit with Euler. We talked about ln of x, and ln of x meaning log base e. Log base e of x is the same thing as ln of x, and so when you're doing these values, we also know that e has a value of 2.714, and this is another. This is a natural log, and it looks like this, which is similar to the logarithm. And so we'll get to this. These are just the two values, right? This one is a log of x equals y, and this is ln of x equals y. They are different because the inverse of this is the 10 to the x power, right? 10 to the x power, and the inverse of this is e. And so what you're thinking is you should be thinking is we still have 1, 0. See that? These are the same. We still have asymptotes here, but this value up here is like 2.7, 2.171 instead of 10.1. And then we'll have some values like this. So in closing, going over learning targets, solving an exponential equation with any positive constant. We did that. We used base 10. We also used some different bases. We learned the definition of a logarithm, and yep, you have homework. Homework is page 267, 1 to 23 odd. And that actually shouldn't take you too long, so I would expect that you would move on to 6-9, especially since we did several problems in class regarding that. So thanks for watching. Sorry for being so long, but thanks for watching.